What if everything you thought you knew about the sun, the glowing heart of our solar system, was only a fragment of the true story? What if the reality is far more volatile, far more dangerous, and far more intimately connected to our daily lives than you ever imagined? Each morning, as we rise from sleep, the sun greets us with its familiar radiance. Its light spills across mountains, forests, and cities, bringing warmth to skin and life to everything it touches. For millions upon millions of years, this cycle has shaped every creature and every ecosystem on Earth. From the first cyanobacteria photosynthesizing in ancient oceans to the bustling cities of today, the sun's energy has written every chapter of our planet's story. But beneath this comforting regularity, there lurks an unsettling truth. The sun is not a gentle, eternal guardian. It is not a constant, unchanging lantern in the sky. Instead, it is a living, breathing, unstable engine, a turbulent cosmic furnace locked in a multi-billion-year countdown to catastrophe. Our planet's fate, and the fate of everything we cherish, is bound to the sun's shifting moods and inevitable demise. One day, the sun will end its life in spectacular violence. Slowly, almost imperceptibly at first, it will begin to exhaust its hydrogen fuel. Its core will contract and heat up, triggering explosive changes. The outer layers will balloon out, transforming our familiar yellow star into a monstrous red giant. Its surface will expand outward, first swallowing Mercury, then Venus, and finally Earth itself. Imagine the oceans boiling away in a torrent of superheated steam. Picture continents melting into rivers of glowing rock. The atmosphere, stripped and scattered, will vanish into space. Eventually, even the iron heart at our planet's core will be consumed in the sun's fiery embrace. This is not science fiction. Every star like our sun meets this fate, a fate written in the relentless mathematics of stellar evolution. But this ultimate annihilation is not the whole story. It is only the climax of a much longer, far more intricate tale. The ending of Earth did not begin in the distant future. It was set in motion over 4.5 billion years ago when the sun itself was born from the ashes of ancient stars. Its journey is still unfolding, step by step, epoch by epoch, leading us ever closer to oblivion. Every sunrise is a tick of a cosmic clock. The question is not when this will happen, but when. The threat is not limited to the far-off future. The sun is a cauldron of chaos, even now. Titanic storms, violent flares, and tangled magnetic fields threaten life and technology right here in our time. A single blast of solar fury, a coronal mass ejection, can cripple satellites, knock out power grids, and plunge entire countries into darkness. In the year 1859, the Carrington event sent auroras blazing as far south as the Caribbean and set telegraph wires on fire. If a storm of that magnitude struck today, experts estimate the economic damage could reach trillions of dollars, dwarfing even the worst natural disasters in human history.
We are far more vulnerable to the sun's tempests than most people realize. Our civilization's infrastructure, communications, navigation, finance, even basic utilities hangs by a thread, all dependent on delicate electronics and satellites that could be wiped out in an instant. To ignore these dangers is to risk not only modern comforts, but the very foundation of our world. The sun, for all its life-giving warmth, is a force of nature that does not care about our plans, our cities, or our dreams.
To truly grasp how Earth's fate is sealed, we must journey beneath the sun's blinding surface and uncover its origins, its hidden layers, and the unpredictable forces that boil within. Only by exposing the sun's true nature can we understand how the same star that gave us life is destined to become our destroyer. Our journey begins in a cold, dark corner of the Milky Way, more than 4.5 billion years ago. Here, a vast cloud of gas and dust, a giant molecular nebula, drifts in silence. This cloud is seeded with heavy elements, carbon, oxygen, iron, and more, forged in the deaths of long-vanished stars. When the shockwave of a nearby supernova rips through the cloud, it triggers a gravitational collapse. Dense knots of matter form and contract, spinning faster as they shrink. In the heart of one such knot, pressure and temperature soar, until, at last, a new star ignites, our sun. The very atoms in your body, every molecule of oxygen you breathe, every speck of calcium in your bones, were born in this cosmic forge. Our sun is not a solitary creation. It is part of a grand cycle of birth, death, and rebirth that has played out countless times across the universe. Similar clouds, scattered throughout the galaxy, are giving birth to new stars even now. The Orion Nebula, visible on clear winter nights, is one such stellar nursery, a place where the next generation of suns are being born. At the core of the newborn sun burns a sphere of pure energy, a thermonuclear furnace where unimaginable pressure and heat force hydrogen atoms to fuse into helium. This process, called nuclear fusion, transforms millions upon millions of tons of hydrogen into energy every second. To put that into perspective, every second, the sun converts over 600 million tons of hydrogen into nearly 600 million tons of helium, releasing energy equivalent to the detonation of billions of nuclear bombs. Fusion is a marvel of quantum physics. Under the extreme conditions in the sun's core, hydrogen nuclei, protons, are forced so close together that they overcome their natural repulsion. Quantum tunneling allows them to slip through barriers that would be insurmountable under ordinary circumstances. The result is a chain reaction that creates helium, neutrinos, and a flood of energy that powers the sun's brilliance. But this energy does not reach us instantly. Instead, it faces a grueling journey outward. The first barrier is the radiative zone, a dense shell surrounding the core. Here, photons, particles of light, are trapped, bouncing and scattering among atoms in a relentless game of cosmic pinball. A single photon may travel only a fraction of a millimeter before being absorbed and re-emitted in a random direction. The path it takes is so convoluted that it may take hundreds of thousands or even millions of years for a photon to escape this region and reach the next layer. To visualize this, imagine a person trying to walk across a crowded stadium, but being stopped and redirected by every single person they pass. The distance may be small, but the journey is almost endless. Similarly, the energy produced in the sun's core today will not emerge at the surface for eons. The sunlight that warms your face may have started its journey before human civilization even existed. Rising above the radiative zone is the convective zone, a vast churning ocean of plasma. Here, the temperature and density drop enough for energy to be transported by convection, much like boiling water in a pot. Huge bubbles of hot plasma rise toward the surface, cool, and then sink back down, creating a turbulent, ever-changing pattern. Each convective cell is wider than the entire continent of Asia, and these cells move energy to the sun's surface in a matter of weeks. Between these two regions lies the tachocline, a razor-thin, mysterious boundary where the sun's rotation abruptly changes. Deep inside, the radiative core rotates slowly and steadily, while the convective envelope above spins faster at the equator and slower at the poles. This shearing layer is a dynamo, generating powerful electric currents and amplifying magnetic fields. Here, the seeds of sunspots, solar flares, and magnetic storms are sown. It is a place of wild, unpredictable energy, where the sun's internal machinery becomes visible on a cosmic scale. Above all these layers, the sun's atmosphere unfolds in three distinct regions: the photosphere, the chromosphere, and the corona. The photosphere is the visible surface we see with our eyes, a mottled sea of bright and dark granules, each the size of Texas. Above it, the chromosphere glows with a crimson light, best seen during a total solar eclipse as a thin, flaming rim. Higher still, the corona, the sun's ethereal outer halo, boils at temperatures of millions of degrees, far hotter than the layers below. The corona's heat remains one of the great mysteries of astrophysics.
How can the outermost layer of the sun be hundreds of times hotter than its surface? Scientists have proposed many ideas, from waves of magnetism to nanoflares, but the answer remains elusive. Each layer of the sun holds clues to its behavior and its dangers. Failure to understand the sun's inner workings leaves us vulnerable to its fury. Solar eruptions, flares, and coronal mass ejections can disrupt satellites, cripple power grids, and threaten astronauts in space with lethal radiation. The 1989 geomagnetic storm in Quebec, for example, plunged 6 million people into darkness for 9 hours when a solar storm overwhelms the power grid. As we become ever more reliant on technology, these risks grow more pressing. The sun's magnetic mysteries are among the most urgent to unravel. What drives its cycles? What triggers its most violent tempests? The answers could mean the difference between resilience and disaster for our civilization. Every 11 years, the sun's activity waxes and wanes in a cycle known as the solar cycle. During solar maximum, sunspots proliferate across the surface, dark, ominous regions where magnetic fields twist and tangle. These sunspots can be larger than the entire planet Earth. When these magnetic knots snap, they unleash solar flares, bursts of energy that can outshine the rest of the sun for brief moments. Sometimes, these events hurl vast clouds of charged particles into space, known as coronal mass ejections. The scale of these eruptions is staggering. A single coronal mass ejection can contain billions of tons of plasma traveling at millions of kilometers per hour. If such a cloud strikes Earth, it can compress our planet's magnetic field, trigger dazzling auroras, and induce electric currents in power lines and pipelines. The consequences can be devastating: blackouts, GPS failures, radio blackouts, and even damage to spacecraft electronics. History is filled with warnings. In September of the year 1859, the Carrington event, the most powerful solar storm on record, struck Earth. Telegraph operators reported sparks flying from their equipment, and some could operate their devices even after disconnecting batteries. The aurora was so bright that people in the northeastern United States could read newspapers by its light at night. In March of 1989, a less severe storm knocked out power across Quebec, causing widespread chaos. In July of the year 2012, a massive solar eruption, similar to the Carrington event, missed Earth by just a week. Had it struck, the resulting technological catastrophe could have set civilization back by years, or even decades. Our dependence on satellites, navigation, and global communications makes us more vulnerable than any generation before us. The sun's activity is governed by a 22-year magnetic cycle, during which its magnetic field reverses polarity. This cosmic clockwork affects everything from climate patterns on Earth to the safety of astronauts on the International Space Station. During periods of high solar activity, increased ultraviolet radiation can expand Earth's upper atmosphere, increasing drag on satellites and shortening their lifespans. Solar storms can also increase the radiation dose received by airline passengers and crew on polar routes. In 2003, during the so-called Halloween storms, some flights were diverted to avoid dangerous radiation levels. The sun's wild tempers are only one piece of its story. To truly understand its power, we must look beneath the surface, into its hidden structure and the relentless forces that drive its cycles. The solar system's graceful order teeters on the brink of chaos. Each planet follows its prescribed path around the sun, held in place by gravity. But this cosmic choreography is more fragile than it appears. Our sun is not anchored in place. It sails through the galaxy, orbiting the center of the Milky Way every 230 million years. Along the way, it passes close to other stars, their gravity reaching out in subtle ways to disturb the solar system's balance. Even a star passing at a distance of a light year, a distance so vast it defies comprehension, can nudge the orbits of comets and distant objects like Pluto. Astronomers have run countless computer simulations to predict the long-term fate of the solar system. The results are sobering. Over the next several billion years,
there is about a 1 in 20 chance that Pluto will be ejected into interstellar space. Mercury, the innermost planet, has nearly a 1 in 50 chance of spiraling into the sun or being flung outward. Mars is slightly more secure, with about a 1 in 300 chance of being lost. Even Earth is not immune. There is a 1 in 500 chance that our planet will be tossed from its orbit or collide with another world long before the sun's final act. The danger is not always slow and incremental. A single encounter, a passing star coming within 100 times the Earth-Sun distance, could disrupt the delicate balance of planetary orbits in an instant. Planets could collide, scatter into deep space, or be drawn into the sun's fiery maw. The solar system's clockwork, so stable over human timescales, could shatter in the blink of a cosmic eye. Similar events have shaped the history of our solar system. The early solar system was a place of violent chaos, with planetary migrations and collisions reshaping everything. The leading theory for the formation of the Moon, for example, is that a Mars-sized body collided with the young Earth, blasting debris into orbit that eventually coalesced into our satellite. In the distant future, another cosmic accident could upend everything. Yet, while these threats loom over eons, the greatest mystery lies much closer, inside the sun itself. Recent discoveries suggest the sun harbors secrets far more urgent for our understanding, secrets that could shape our future in ways we are only beginning to imagine. Unlocking the sun's smallest secrets may be the difference between survival and catastrophe. For centuries, people gazed up at the sun and saw a calm, unblemished star. But with the advent of powerful new telescopes, such as the Daniel K. Inouye Solar Telescope in Hawaii, we have gained a sharper vision. The sun's surface is revealed as anything but smooth. These instruments expose magnetic structures so minuscule that they are narrower than the span of a city street. These delicate, twisting threads are the sun's magnetic fingerprints, invisible to every civilization before ours. Why do these details matter? Scientists now suspect that these microscopic magnetic strands are the missing link in the sun's most violent tempests. Buried beneath the churning surface, tangled fields of magnetism writhe, snap, and reconnect. When they do, they can hurl forth solar flares and coronal mass ejections, eruptions more powerful in a blink than all of humanity's energy use over centuries. These are not rare curiosities. They are the hidden engines behind the sun's wrath. The stakes could not be higher. Our world is woven together by fragile technology, from orbiting satellites to sprawling electric grids. A single, well-aimed solar superstorm could shatter that web in moments, knocking out navigation, communications, and power for millions. The fallout could rival the devastation of a major war, even though not a single weapon is fired. In truth, the sun's magnetic tantrums are now among the most underestimated threats to modern civilization. That is why real-time solar monitoring has become mission-critical. Across the globe, networks of observatories and satellites track every flicker on the solar surface. Their task? To forecast dangerous space weather, buying precious hours, or even minutes, of warning before disaster strikes. Scientists are racing to decode the sun's quietest whispers, tiny ripples in the magnetic field that could foretell tomorrow's geomagnetic maelstrom. Each discovery in solar physics is more than knowledge. It is a shield. By charting the sun's micromagnetism, we can build smarter early warning systems, reinforce our digital infrastructure, and safeguard astronauts who venture beyond Earth's protective cocoon. But if we ignore these clues, we leave ourselves exposed, trusting our luck against forces older and stronger than our entire species. Our fate is now interwoven with our ability to interpret the sun's magnetic moods. The margin between resilience and ruin may lie in patterns measured in mere miles. Structures smaller than a mountain, but with the power to decide civilization's future. As we probe deeper into the sun's mysteries, we are buying time for our world. Every insight is a lifeline. But what can we do, practically, with this knowledge? The answer lies in action on multiple fronts. On a personal level, learning about space weather and its impacts can help individuals and communities prepare for disruptions. Governments and power companies can harden electrical grids against geomagnetic surges, install backup generators for critical infrastructure, and develop rapid response protocols for satellite operators. International cooperation is essential. Solar storms do not respect borders, and a warning system in North America is only useful if it is shared with Europe, Asia, Africa, and beyond. Astronauts and space agencies are already adapting. The International Space Station is equipped with radiation shelters where crew members can take refuge during solar storms. Future missions to the Moon and Mars will need even more robust protection, perhaps incorporating underground habitats or magnetic shields. In the long term, understanding the sun's cycles will be crucial for planning everything from air travel to telecommunications. Schools can include solar science in their curricula, inspiring the next generation to become the scientists and engineers who will tackle these challenges. Citizen science projects, such as the Galaxy Zoo or Sunspotter, allow ordinary people to contribute to our understanding of the sun, turning curiosity into real progress. Yet, all things change. The sun, for all its brilliance, is not eternal. So, what awaits us in the star's final act? The answer could rewrite the fate of the solar system itself. To understand our ultimate destiny, we must witness the sun's dramatic transformation as its life nears its end. The final chapter is closer and stranger than we ever imagined. The sun is middle-aged, about halfway through its 10 billion-year lifespan. For more than 4.5 billion years, it has burned steadily, providing the right conditions for life to flourish on Earth. But nothing in the universe lasts forever. In about 5 billion years, the sun will exhaust the hydrogen in its core. Fusion will slow, and the core will contract under gravity, heating up even further. This will ignite a new phase of fusion, involving helium, and the sun's outer layers will swell to hundreds of times their current size. Earth, if it survives gravitational disruptions, will be consumed. What will this look like? Astronomers have studied aging stars, red giants, in distant corners of the galaxy to glimpse our future. The star Betelgeuse in the constellation Orion is one such red giant. Its diameter is nearly 1,000 times that of the sun, and if placed at the center of our solar system, it would engulf the orbits of Mercury, Venus, Earth, and Mars. Our sun will not grow quite as large, but it will become a bloated crimson sphere, casting a hellish light over the remains of its inner worlds. During this phase, the sun will shed huge amounts of mass into space, forming a beautiful, glowing shell called a planetary nebula. The exposed core, now a white dwarf, will cool for trillions of years, fading into darkness. The solar system, once so vibrant, will be a graveyard of frozen planets and drifting debris. This is not a unique fate. Every star similar to the sun follows this path. Astronomers have observed planetary nebulae throughout the galaxy, ghostly remnants of stars that once shone like ours. The Ring Nebula in the constellation Lyra is a vivid example, a cosmic tombstone marking the end of a sun-like star. Yet, this is not a tale of despair. It is a call to wonder and responsibility. We exist within a brief, precious moment, balanced between cosmic dawn and cosmic dusk, a moment in which understanding our star can still shape our destiny. To value the science of the sun is to value our survival, our curiosity, and our place in a universe where nothing endures forever. In the grandest sense, the sun is our cosmic teacher. By studying its layers, its rhythms, and its inevitable demise, we glimpse the fate awaiting all stars and all worlds. One day, in a time beyond human memory, the sun will swell into a red giant, swallowing Mercury, Venus, and Earth. The oceans will boil, the rocks will melt, and every trace of life will return to dust, completing a cosmic cycle that began billions of years before our birth. We are children of the sun, tethered to its brilliance and bound to its fate. From the first spark of hydrogen igniting in the sun's heart to the searing expansion that will one day erase every memory of blue sky and green earth, our destinies are entwined with that incandescent sphere at the center of our solar system. This is not the gentle, eternal lantern our ancestors imagined, but a turbulent, unpredictable engine, a cosmic clockwork counting down the ages. In the end, the story of the sun is the story of us. Its fire sparked our beginnings. Its final flare will mark our end. Every sunrise is a reminder that we are part of something vast, ancient, and awe-inspiring. To know the sun is to know ourselves, and to glimpse the fragile miracle of existence in an ever-changing cosmos. So the next time you see the sunrise, remember, you are witnessing the latest chapter in a story that began billions of years ago and will continue long after we are gone. The sun is both our cradle and our destiny, a reminder that we are, in every sense, children of the stars.